Let's take a look at finding confidence intervals with our calculator, using TI-83 or 84. Now, we went through quite a process to find a confidence interval before. We first had to figure out what z-scores corresponded to the level of confidence. And even once we had those, we still had to figure out our x values using the z-score formula. Turns out that you can do all of this on your calculator in one easy process. Now, don't kill me for not showing you this yesterday, but nonetheless, here we are. So, if you go to your calculator and you hit the Stat key, then you go over to Tests. So there's Edit Calc, and this is the one that we haven't used yet, Tests. You can go down, you have all these different tests, and then you have below that a bunch of different types of intervals. So I'm going to go back up to 7. 7 is Z interval, and Z, thinking of our z-scores, is referring to the standard normal curve. And so we're going to use Z interval, and our input, we're going to use stats, because we're given some numbers. We're given x bar, we're given sigma, and we're given n. And so if we select stats, our sigma is 120. Our x bar is 2178. And our sample size n is 34. So you pop all those values in, and our confidence, if we're at a 90% confidence, we'd want to type in 0.90, or it'll just go back down to 0.9. And after we have all this information in here, we just hit calculate, and boom, there's the answer. So it's really not too bad to do. So if we want to take a look at what this actually means, it means that you are 90% confident that the population mean is between 2144 and 2211. Remember, the whole point here is what we're trying to do is say, where is the actual population mean? Now, this problem doesn't have any context to it, but let's say we are looking at the number of shipments per day at some center. The measurement that we took here, this 2178, this was the average of 34 measurements, 34 days that we had randomly sampled. And so using our formula for confidence interval, we can say that even though we don't know exactly what the true mean is, we are 90% confident that it falls between these two numbers. So again, our calculator lets us skip through some of the process that we had to go through before. So let's take a look at the next one. Before we do that, I want to introduce you to a new curve called the t-distribution. So what we've been looking at is the standard normal curve, or the z-distribution. Now we're going to look at t. It turns out that t is not one curve, but a family of related curves. The blue curve here is the normal curve, and the red curve is one of the t-curves. And it says here 1 degree of freedom. It's the image from Wikipedia, our trusty source for everything. 1 degree of freedom means that there's a sample size of 2. We're not going to talk about that a whole lot in class, but that's just something, if you see that, that's what it's referring to, is it's related to the sample size. So at a sample size of 2, you only took 2 people in your sample, you would see that the middle is a little bit shorter, and the tails are a little bit wider. And so really what this curve, what this distribution is it's kind of like a normal curve, but a little bit stubbier on the ends. Now let's look at it if you use 2 degrees of freedom, which means a sample size of 3. So a little bigger sample. The green curve is just referring to the old one in this last diagram, and the red one is the new one for a sample size of 3. You can see it's a little bit taller, a little bit closer to the normal curve, but still same general idea. Fatter in the tail is shorter on top. We have 3 degrees of freedom, a sample size of 4. You can see it got a little bit taller yet, a little less wide on the tails, and so forth. And that continues where, okay, with a sample size of 6, it's getting closer and closer to the normal curve. Sample size of 11 here, it's getting very close. And by the time you get up to a sample size of about 30, you've effectively hit the point where the t distribution and the z distribution are the same. So what does this mean for us? It means that whenever we have a small sample size, that it's actually more accurate to use the t distribution to do our calculations. So before on our calculators, we went to stat tests and we went down to z interval here. Instead, now we're going to use t interval whenever we have a small sample size. The reason that you would only use it on the small ones and not all of them in the olden days was that it was a lot more work to find a t interval than it was a z interval. The intervals went pretty quick. However, for the rest of this class, we're going to stop using z interval. You're never going to go to option 7. And the reason is that if your calculator is doing it anyways, it doesn't matter how big your sample is. If the t interval is always going to be accurate, let's just use that. So that's what we're going to do. We're going to use t from now on. So let's look at the confidence interval. Now this problem has a x-bar, a mean of 314, standard deviation of 36. Notice the difference in notation. I use SX instead of sigma because in this problem I'm going to assume that I don't actually know the population sigma, which is one of the assumptions you have to make when you're using the t distribution, whereas if you truly know the sigma for the entire population, that's when it's technically safe to use the normal curve. Again, we're not going to worry too much about the details behind that, but just know that when you take a sample and you find the standard deviation of that sample, that number comes out a little bit differently than if you knew the entire population. Last thing here, our sample size n is 12. So we need to find a 95% confidence interval. The way that we're going to do that, we're going to go down to our t interval. Remember, stat tests t interval, select that. Again, we're going to choose stats as our input method. X bar is going to be 314. SX, our standard deviation, is 36. And N, our sample size, is 12. And we want a 95% interval, so we're going to type in a C level of 0.95 and go down to calculate. Now you'll notice that it takes the calculator a little bit longer to figure out a t interval than a z interval. That's because it's a lot more work to do that. However, given that it's a calculator and it takes only a second, we don't really care. So that's okay. Anyways, our t interval here comes out to be something between 291 roughly and 337. So it's gonna, we are 95% confident that the population mean is between 291.13 and 336.87. So that is the interval where we think the true mean of the population falls. Again, we did this the same way we did the z interval, just this time we selected t interval, and instead of having sigma here, like we did earlier, instead of having sigma for our standard deviation, we use SX, which refers to the sample standard deviation. Last thing we're going to look at is a list of numbers. Now, just like the first two problems, which I pulled from the last homework to show you how much easier it is to do it this way, this is the very first problem on the last homework assignment. It has this list of numbers on the very top. And we had to do quite a bit of work in order to calculate the confidence interval for this. Well, this time, what we're going to do, we're going to start the way you'd expect. We're going to go to our stat edit, we're going to fill in our stat list, clear whatever data we have in there now, and let's go ahead and punch these values in. 10, 12, and I'm going to skip ahead so that I don't bore you as I type in numbers, but type in that whole list there. Alright, I got all the numbers typed in here, and once you get to the end of your list, what you need to do is go ahead and go back to stat. We're not going to go to calc in one bar stats like we usually would. This time we're going to skip straight over to tests. We're going to go down to t interval number 8, or you can just push 8 on your calculator. And we're going to, this time, instead of selecting stats, we're going to go to data and enter. Select data. Under list, it should default to L1. If it doesn't, you can change it to one of the other lists. But we have L1 as our list. Frequency should always be left as 1, because we're not trying to double the list or anything like that. And then we set our confidence level. Let's say it's 95%, so we would set it at 0.95. And go down to calculate. And you're going to love this. There's our answer. All we had to do is type this into our L1 list, set it at 95% confidence, and the calculator does the rest. So we are 95% confident that the population mean that this sample was drawn from, the population mean, is between 7.7342 and 9.8658. Now these numbers are very precise, probably more precise than the data we have should allow it to be. But nonetheless, we are able to produce a 95% confidence interval based on this data. Now, I'm using these numbers a little bit out of the original context they were taken. Originally, this was the entire population, and we were drawing a sample from it. But for the context of this problem, imagine that these numbers were pulled from a much larger population, and we are generating the confidence interval where the true mean of the entire population. That's the whole point of all these inference things that we've been doing with confidence intervals. We don't know the population mean. In fact, usually there's not really a way to know exactly what it is. So the best thing we can do is make up an interval that tells us where we think it is and how likely it is to be there. So you can sacrifice your confidence to get a smaller interval. So you can say, I'm only 90% confident, but I'm 90% confident it falls within a pretty small range. Or you can sacrifice the interval to be much more confident. You're 99% confident that it falls in a little bit bigger range. So again, your calculator is the tool that you're going to want to use in order to solve these. You're going to go to Stat, Tests, and down to number 8, which is your t-interval. If you have a list of data, you'll select data and you'll type it in your L1. If you're just given x bar, the standard deviation in your sample size, you'll use stats and type those numbers in here. That's the end.